Hi everyone, very good evening and welcome back to GFG practice. Please give me a +1 in the chat if my voice is clearly audible to everyone and everything is working fine. Then I'll share my screen and we'll discuss the problem of the day for yesterday. That was nothing but Kth permutation. Okay, so hi Rishit and hi Naikaj. I hope that everything is working fine and the audio is also fine. So I'll share my screen so that we can discuss the problem for yesterday. Thanks a lot, Rishit. Okay, so yeah guys, you can give a thumbs up to the video and give me a +1 if everything is working fine, and we will discuss the problem, that is Kth permutation. Okay, so what is the name of this particular problem? The name of this problem is that you have to find, okay, you have to find what? Find the Kth permutation. Okay, find the Kth permutation, right, of n natural numbers, of n natural numbers, right? So what does this thing mean here? Suppose that we have a particular n value, right? So like suppose that we have a particular n value. Let's suppose n value is 3. Okay, then the first thing will be 1 2 3, right? The first permutation will be 1 2 3, then the second permutation will be 1 3 and then 2, then the third one would be 2 1 and 3, then the fourth one would be 2 3 and 1. Okay, after that the next one will be 3 1 and 2, and then the next one will be 3 2 and 1. Okay, so if I will number these permutations, so this is the first permutation, second permutation, third permutation. Okay, this will be the fourth permutation, this will be the fifth one, and this will be the sixth one, because if n is given, so n is equal to 3 means we have three numbers, 1 2 and 3, and we have to find the kth permutation. So suppose we might have to find the fourth permutation, then we will return this particular permutation, or if we have to return the fifth permutation, then we will return this particular permutation. So depending which permutation has been asked, so that one we will return. Is this part clear to everyone? Please write yes in the chat, guys. Is this much part clear to all of you? Please tell me in the chat, right? That you will be given a particular k value and you have to return the kth permutation, right? Is this much part clear to everyone? That you have to return the kth permutation. So let's say if I'll give k value as 4, then you have to return this fourth permutation here. That is the thing. Okay, Anand Chaurasia and Roaster and Naikaj and everyone is clear. How do we decide the order of the permutation? So basically we decide the order of the permutation based on the lexicographical order, or you can say that we decide it based on the alphabetical order, you can say, right? Lexicographical order. So from smaller to higher we are going now. So you can see 1 to 3 is the smallest permutation, so it will be the very first permutation, and 3 to 1 is the largest permutation that is possible, so it is the last permutation or the sixth permutation. Okay, is that clear? So basically now if the n value is 3, so the total number of permutations is nothing but n factorial. Okay, so which is going to be nothing but what? This is going to be nothing but 3 factorial, that is nothing but 6. Okay, so total 6 permutations will be there. Is this much part clear to everyone? Please tell me, guys. I hope that this part is clear. Now what I can see is that if I have to generate all the possible permutations now, so what is the basic thing that comes to my mind when I have to generate all possible permutations, right? When I have to generate all possible, right, all possible permutations. Okay, so then in this case what comes to our mind? Recursion comes to our mind. Okay, when we have to generate all possible ways or something like that, so please write rec in the chat. Okay, hi Arohi as well. So recursion comes to my mind. Okay, so then recursion will come to our mind. So in recursion, if you will generate the using the recursive approach, if you will generate the all possible ways, so like it is going to take n factorial time, right? Because for generating if n natural numbers are given and you have to generate all permutation, so it is going to take n factorial time, and you will be storing it in a data structure also, so you will make a deep copy of it, so it will take order of n time more. So this will be the time complexity, right, which is going to be very high, and the space complexity is also going to be very high, right? So is this part clear? Method 1 is clear. If we had to do it normally, then what we will do is we will just use a recursive approach, and after that we also have to sort what, like all the list that we are having, we will sort the list, all the list in ascending order. Finally when we have all the list now, when we will be able to generate all the list, so we will sort those lists in the ascending order, and then we'll return the kth list. And if suppose we are storing in the zeroth format, so we will return the list k minus 1, because indexing will be zero base, suppose, in the list, right? So is that clear to everyone? Please write +1 in the chat and hit the like button, guys, if it is clear to everyone. Okay, is this much part clear? Then I can proceed further. Okay, Rishit says it is clear. What about others? Others must also be clear, I think. Right. Now, in this case, let us take a sample example. Okay. So, in this case, if you will see, suppose that suppose that we have n is equal to 4. Okay. Suppose that what I will do is I'll take n is equal to 4 here. Okay. If I'll take n is equal to 4, so suppose I have four natural numbers, and suppose I will take the k value as let's say if I'll take the k value as something like 21. Okay, let's say if I want the 21th permutation. Okay, so in that case, what will, if the k value is 4, so total how many permutations will be there, guys? Total 24 permutations will be there, because total 4 factorial permutations will be there. So total 24 permutations are going to be there. Is that clear? Right. Now in this case also, now if you will observe, so let's say if I have 1 at the very first position. Okay, so after that I have to take the choice of 2, 3 and 4. I have to pick amongst 2, 3 and 4. So using them I can make 6 permutations, right? If I have 1 at the first place, then using rest of the numbers I can make how many? 6 different permutations, no? Because if 3 numbers are there, so 3 factorial permutations will be possible using them. Okay, order of the permutation, like I will sort the permutation na, in the lexicographical or the ascending order, you can say. So then I will get the permutation Anand. Is that clear, Anand? Right. Now you can see, suppose that if I had one, if I like, if total I'll have 24 permutations here. So how can I decompose it? So I can say that if suppose one was at the first position, then I will have how many permutations? Then after that, if I have 2, 3 and 4 for the second, third and fourth position respectively, then amongst them I can make 6 permutations, right? Then after that, if I'll have two at the first position, then I can place what, 1, 2 and nothing but 3. Okay, so then after that I can say that again I can make 6 permutations using 1, 2 and 3. Then if I have 3 at this place, then using what, using 1, 2 and 4, I can again make 6 more permutations, right? With 3 being at the first place. Okay, then if I have 4 at the first place, then I can have what, 1, 2 and 3. So I can again make 6 permutations. Is that clear to everyone, guys? Right, so that is how we will be having total of 24 permutations. Is that clear, guys? Are you getting this point till now? Is this clear, guys? Till now, is that clear to everyone? Okay, so initially what I will do is, suppose in a data structure I will store 1, 2, 3, 4 every number. Okay, so suppose like in an array 1, 2, 3, 4 I will store, and suppose I am storing it in zero based indexing. Suppose this is 0, this is index 1, this is index 2, this is index 3. Okay, and what I can assume is, suppose that I will assume the permutations 0th permutation till 5 permutation. Okay, if I'm having a zero based indexing in the permutation. Okay, in the permutation numbering. So then the next permutation will be what, from 6 to I think 11. Then the next permutation will be from where, 12 to 17, and the next permutation will be from 18 till 23. Right, this is going to be the case. Right, this is going to be the case. So if you will observe here, if I'm having the k value as 21, guys. Okay, if I'm having the k value as 21, so if I'm having the k value as 21, okay, so you can see here 6 permutations are if you will see, I'll use a different color. So you can see that I am using 6 permutations here, 6 permutations here, 6 permutations here. So total 18 permutations will be here. So that means the 21st permutation will be coming in the part when 4 will be at the first place. Is that clear? Please write 4 in the chat, guys. Are you getting this point? When 4 will be at the first place, then I will get this thing. Is that clear to all of you, guys? Are you getting this point? When 4 will be at the first place, then I will get the 21st permutation. So in the 21st permutation, I can see that 4 will be at the first place. All right, everyone is writing yes. Very good, guys. So what, how can I directly say that? So if you will see, so like as I said, I will have 18 here till here, and from 18 till 23 I'll have the permutations here. Okay, so what I want to say is, if the k value is 21, so initially I will say that I will do k minus minus, because I will make it zero based index, right? Because suppose if I'm having zero based indexing, so 0 till 5 permutations, so I have to make this 20 as zero based. So in that case I'll do k minus minus and I'll do 20. Okay, then after that, when I'll divide 20 by 6, so what will I get, guys? What will I get if I divide 20 by 6? So I am going to get 3. Okay, so suppose this is the zero based order, right? So you can see that 1 is placed at the 0. Like, see, when I divide when I do what, when I divide k by like when I divide k by 3 factorial, right? Are you getting my point? When I divide k by 3 factorial, because n value is 4, so initially I am having initially I'm storing in the factorial, I'm storing 3 factorial here. Okay, so if I have k as 20, so I'm dividing 20 by 6. So what do I get? I'm getting 3. So this means indirectly I'm getting this particular index. Are you understanding this point, guys? I'm getting this particular index, the third index. So which guy is there at the third index? The guy is there, the guy there is 4. So this means at the very first place, which guy I will be placing? At the very first place, you can say that I'll be placing 4. Is this much part clear to everyone? Please write yes or no in the chat, guys. Are you all clear with this part? Please tell me in the chat. Okay, so when I'm doing k, like, see, I will have k value as 21, but since I'm having zero based indexing, so I will do a k minus minus, right? Because the indexing will be zero based. That is what I am assuming in my numbering. So in that case, that actually I will have to find the 20th permutation if the permutation starts from 0. So if I'll do 20 by 6, so if I'll do 20 by 6 now, so what I will get, 20 by 3 factorial, that is n minus 1 factorial if you will do. So initially, because you are having parts of 6 now, you are having this permutation in the, like, in the pieces of 6. So that is why every part is of 6. So in which part it will lie? So when I do 20 by 6, so it is lying in the zero base indexing, it is here 3. So it gives us 20 by 6 gives us 3. So basically it is giving us the index 3, that is nothing but the element 4. Is that clear to everyone? Please write 4 in the chat. So that is how I'm going to get this fourth guy, right? So if I have a nums array, now if I have this array as the num array, so what I'm going to do is I'm going to look for num of k divided by factorial. Okay, so that is how I'm going to get this guy. So that is how I'm going to get num of 3, and num of 3 is going to be nothing but 4 here. Okay, this is going to be the case. Is this clear to Arohi as well, Mihir as well, and other people who are present here, guys? This makes sense. Then after that, if you will observe now, so what has happened till now is, if you will see, so the k value was what? I have made the k value as 20, and the factorial with which I was dividing it was 3 factorial, 1 factorial lesser. So it was 6, right? So in this case, I can say that, okay, after this point, like, since it is 20, so if I'll do 20 modulo 6, right? So what do I get? I get 2. So this means that in this also I want the second permutation. Is this clear? I want the second permutation in 4 also, right? See, in 4, I know that, okay, 4 will be at the top, but when 4 is at the front, 4 is standing at this place, then which permutation of its do I want? So if the k value, if I'll reduce it now, so like, if I have k is equal to 20, so if the k value is 20, right? So if you get this point, that since the k value is going to be nothing but 20, so I can say that it will be nothing but, if when I'll do k modulo 6 now, so then what am I going to get? I'm going to get the value as 2, right? So this means that in this I want the second permutation. Is this part clear to everyone? Please write yes in the chat. Like, there will be, like, see, 4 will have 6 permutations, but I want the second permutation of 4 being at the first place. Please write +1 if you are clear, right? 4 will have 6 different permutations, right? Because 4 has what? 1 2 and 4 has got 1 2 and 3. So my task is that, since I have used 4 now, so I am going to delete 4 from this nums array. Okay, when I delete 4 from this nums array, then what is going to happen? Give me a second, I will tell you. When I delete 4 from the array, then the array is going to look like this. Okay, it is going to look like 1 2 and 3. Okay, and I'll index it 1 2 0 1 2, and the k value was 20. So when I was k value was 20, so now in this case I want the permutation when 4 is at the first position. So I can say that I want the remaining. So I can say that if I'll do 20 modulo 6, right, then what am I going to get? I'm going to get nothing but 2. So in 4 I want the second permutation. Is that clear to all of you guys? Please write yes in the chat. This is very important. If you're clear with this point, so please hit the like button as well, so that I can confirm that you are clear, right? Because when you have 4 here now, so when you have 4 at the first place, so since I want the 20th permutation, so I want this like, I want the second permutation in 4. Is that clear to all of us? Are you getting my point, guys? Right. So that is why we need to do this thing, right? So we need to take the modulus. Now once you have taken the modulus, so you are saying that k value will be equal to 2 for you. Okay, so again, if the k value is 2 for all of us, right? If the k value here is 2, so what will we do here? If the k value is 2, updated k value is going to be what? Updated k value is going to be nothing but 2. So we have 4 at the first place, then we have rest of the numbers. So how many numbers do we have here? So we have 1 2 3, right? So if we have 1 2 3, so again, if I place 1 at the first place and I have 2 and 3, so how many permutations I can make if I have 1 at the first place? So I can say that I can make 2 permutations here. If I place 2 at the first place, then how many 1 and 3 will be there? So I can make again 2 permutations out of it. If I place 3 at this position, right, then how many 1 and 2, amongst 1 and 2 I can permute and I can make two more permutations. So that is how I'm going to have total 6 permutations, right guys? So in this case again, what I will do is, since the updated value of k, like since k became what, so k was equal to nothing but k modulo the factorial, right? So then what happened was k is equal to 20 modulo 6, so k became nothing but 2 here, right? Now since k has become since the k value has become 2 here, so what I will do is I can simply say that since the k value is 2, so this will be 0 to 1th permutation, this will be what 2 to third, and this will be 4 to fifth, right? Because if it is 0 base, so 0 0 1, then 2 3 4 5, so this is how the permutation is going to be. So k is equal to 2 means what, that see, I wanted the 20th permutation, okay? If I wanted a 20th permutation, so this meant that one will all, like one will not be here, two will be here. Are you getting my point, guys? If I wanted the 20th permutation, so this means that 18 19 the permutation of 4 starts from where, it starts from 18, so 18 19 and then 20. So I want the, I want the permutation 20th permutation, so this means I want actually the third one, so it will lie here now when 2 is at the front. Is this part clear to all of you guys? Please tell me, does it make sense? So that is why when the k value is 2 here now, after taking the modulus, so we can simply say that when we'll divide the k value by factorial, so factorial now becomes what, now since the new array size is 3, so I'll divide the factorial by 3, because you can see now the factorial value has reduced to 2. So factorial, I will update the factorial, so the factorial will be factorial divided by the size of the array, so it is 3. So now the factorial has become what, factorial has become 2 as well. So when I will do when I'll update the k value, so k is going to be k divided by the factorial, okay? So k value is going to be what, 1, right? The updated k value, you can see the value that I am getting is 1, okay? If I'm getting the value as 1, so that this means that I need to place this 2 here. Is this part clear? Is this part clear to everyone, guys? Because if I place 1, so with the help of 1 I will make 2 permutations, and when I keep 2 here, then I will be able to make the third permutation. That is what I required. Is that clear? We should think of k as 0 based. Yeah, that is what I said now. I'm assuming a 0 based indexing, so when the k value is 2, so this indicates that indirectly I want the third permutation. Is that clear to everyone, guys? Okay, so I want 2 here. So in that case I will get the index as 1. So the which guy is present at the index 1? 2 is present, okay? So I'm going to use this guy 2, and then I'm going to erase this guy from the array. Is that clear to everyone? Please tell me, guys, is this part clear? So I'll place 4 and 2, okay? Is this part clear, that I have placed 4 and then I'll place 2 also, then 2 places remain. And what is going to happen is, I can say that I'll delete the element 2. So now the elements that are there is 1 and 3, and their indexing will be 0, this indexing will be 1, okay? And now the elements that I have left is 1 and 3, okay? So if I keep 1 in the first place, then 3 is going to be there, okay? So this will be one permutation. If I keep 2 here, sorry, 3 here, then 1 is going to be there, right? If I keep at this place, so 1 is going to be here, so one permutation will be there. So I can say that now since I have used the k, right? So k value was 2, okay? K value was 2. So since the k value was 2, so now I'm going to take the factorial, like a modulus with the factorial. So k will become what, k modulus factorial, right? So in that case what happens, k is equal to what, it will be 2 modulo 2, so this will mean 0, okay? So the k updated value of k is going to be 0 here. So now since the updated value of k is going to be 0, and I will see the updated value of the factorial as well, so factorial is going to be 1 here. So since the k value is 0 now, so this means that now I want which number, I want the very first permutation here. So basically this will be the 0th permutation, this will be the 1th permutation. So you can see that I want 1 and then I want 3. So I can simply say that like when I will do k by fact now, so that number I want from the array. So I will want 0 by 1, so that is going to be 0. So I will want this guy 1 here, okay? And then after getting this guy, what we will do is we'll take the modulus. So since the k value is 0, so the modulus will be what, k modulo factorial. When I'll see the updated value of k, so k is going to be what, k will become 0, and then the only then I will delete 1 from the array. So now 3 is going to be only there, and it is present at the position 0. So I have placed 4 here, then I have placed 2 here, then I have placed 1 here, and the last position is there. And if I place 3 only, so there is only one way to do it, right? So then since the k value is 0, and I'll divide the, so the factorial is going to be 1, so I'll divide it by 1, sorry, 0. So now it will be placed at this particular place, right? So I'll like when I'll do k by factor now, so I'll get the index 0, so I'll take this guy and I'll place it here. So that is how I'm going to get 4213, okay? Is this clear? If you will do it using next permutation, so in the interview, the interviewer is going to reject the approach, Rishit. Is this part clear? If you will see here, let me write the value. So if I'll write the 4 value and I'll write 21 here, suppose, so then I should get this particular permutation, that is nothing but 4213. Let's check this out. Okay, you can see here, what I'm get if I'm giving the k value as 4, and initially I'm giving 21 value. Okay, because they are considering one base indexing, so I'm giving the 21st permutation. Then I will do k minus minus, so it will become 20, and you can see that the final answer is 4213, and you can see that is what we are getting here. So is this part clear to all of you guys? Please tell me if somebody is not clear with anything. Like Arohi was there, and Mihir is there, Anand is there, and other people are there. So guys, if you are clear till now, please tell me. If something is still not clear, so then you can tell me, I can explain it again. Okay, in your dry run, how did you delete the middle element? So how did I delete? So I will use the erase function in the C++ for deleting it. So when you will delete now, so it will be another order of n operation when you are deleting. So I'll use an inbuilt function for deleting. So the time complexity is now going to be different, because see, we are generating n steps now. So see, we are having n positions, so we are iterating for the n different positions. Now we are placing n different positions, elements at n different positions. And initially what we had, suppose that we had 1 2 3 4. So whatever element we have picked up, right, we are deleting it from the array. So at one step, right, at one step, total n steps we are having. At one step, the deletion will take order of n time. Okay, so since you are generating n, since you are doing it n number of times, so overall it will be order of n into n, that is nothing but order of n square. So now the complexity of the code is going to be order of n square. And since you are doing it n number of times, so the complexity is going to be order of n square. So now the complexity of the code is going to be order of n square. And since you are doing it n number of times, so overall it will be order of n square. So is this part clear to all of you guys? Uh, are we back or not? Just a second. Can you hear me, guys? Just let me know. Let me check as well. Okay. Yeah, fine. Right. So what I'm saying here is, since you are generating for n positions, so for one position you are taking order of n time. So for n positions you are taking n into n time, right? Because one position, the deletion takes how much times? For one, if you are deleting one element, so the deletion takes order of n time. So if you are generating for n places and you are deleting the elements one by one in the array, so overall n into n will be the complexity. That is nothing but n square. So is this part clear now, guys? I'm talking about the next permutation. Next permutation is going to take n factorial time, Naikaj, because it is going to generate a lot of permutations, I think, if you are using next permutation. So if you are generating all possible permutations, so it is going to take a lot of time actually. Okay, so like, are you clear with the idea, guys, or not? Please tell me. Like, see, as I initially told you, if somebody is going to ask me again, so I'll say that, suppose that n value is 4, and they want what, let's say they want the k value as suppose 15. Okay, they want the 15th permutation for it. Okay, so no, let me share my code. Yes, you can share it. So see, if the n value is 4, guys, and the k value is 15, so I can say that I can distribute it in the batches of 6, because if I have one here, then I will have 3 more positions, right? So I can say that I have six combinations that I can make, right? Then if I place 2 here, then how many combinations I can make? 6. Then if I place 3 at the first position, how many combinations I can have? 6. Then after that, if I'll have 4 at the first place, then I can make 6 combinations, right? So if the k value is, let's say, 14, and I'm considering a zero based indexing, so 0 to 5 is here, then 6 to 11 is going to be here, then 12 to 17 is going to be here, and then 18 to 25, sorry, 23 is going to be till here, right? So if I want the k value is 15, so first of all I'll decrease the k value. So the k value, I will assume it as k minus minus, so k will be 14. So if I want the 14th one, so it will lie here when the 3 is at the front. Is that clear? How did you get the idea? So Arohi, the idea comes from the dry run itself, right? Like, see, when you used to prepare for the JE days, na, Arohi and Naikaj and Rishit and everyone, when you used to prepare for the JE mains examination, then in that case, if somebody will tell you to give them the 15th 15th permutations, and if you are going to take a zero based indexing, so first of all you will do a k minus minus, right? So k will become 14, because I'm considering a zero based indexing here. So then you can say that this in this when 3 will be lying at the first position, so then I will get my permutation. right? Then I will get it. Is that clear to everyone? So is this part clear or not? Like when, where will you find it? So in this case, if you have an array, and in that array, first of all you'll store 1, 2, 3, and 4, okay, and you will do the indexing 0, then 1, then 2, and then 3, right? If you do the indexing of it, then if you will see, so this is the 0th club, right? This is the 1th club, okay, this is the 2th club, and this is the 3rd club. So if you have the k value, so you have 14. If you do 14 and groups are of 6, so this means you have to take like you have to divide it by initially n minus 1 factorial. So initially the factorial value will be nothing but n minus 1, because if n value is 4, so 3 factorial is nothing but 4 factorial is 24, 3 factorial is 6. So initially you can say that factorial will be equal to what? N minus 1, like n minus 1 value. So fact, when I'll divide it by fact, so 14 divided by 6 will give us what? It will give us 2. So when it gives us 2, so the indexing is 2, so this will mean that I want 3 at this place. Is that clear? So that is how I can retrieve this, that okay, I can get 3 from the array. So that is how we relate the logic with the code part. Okay, so since we are taking the zero based indexing now, so that is how it can help us. Is this part clear to guys, you guys, or not? You can try to share it in the chat. I think it will be shareable. Is this part clear? That, see, I want the second, like if according to the zero based clubbing, I want the second one, right? So in the second one, I have three as the starting, if I consider 0th, 1th, second, and third group, right? So if I'm having four groups which are numbered from 0 through 3, so I want the second group in which 3 is the starting guy. So I can simply say that what I will do is, if I do k by factorial, that is 6, then I will get this particular index as 2. So this will be this k by fact is always going to tell me the index that I want to take from the array, right? From the current num array, right? This is a num array. So I will take this particular guy at the index 2. So the guy will be 3. So I will be able to take this guy. Is this part clear to Arohi and everyone? Guys, please tell me. Is this part clear that I am taking 3 from here? Yes or no? Please tell me. Are you getting this point, that I'm taking 3 from here? Right. So once I take it, so I will have to delete it from here also. So the deletion for one, if I'm deleting one element, so it takes order of n time. And since I'm going to generate for n places, so it will take order of n square overall time, right? So the overall complexity will be order of n square, right? Because n steps I'm having, and in every step I'm deleting also. So in one step, if I'm deleting, it takes order of n time for deletion, right? So supposing it is a middle element or last element, so in the now worst case, it takes order of n. So for n places, it will take n square time, right, guys? Okay, so suppose that I want 14. Okay, remember this, that I want 14th here, right? So if I want 14th here, so I will have 3 at the starting, right? If I have 3 at the starting, then after that, k value was 14, okay, and the fact value was what? Fact value was nothing but also one more thing, when I will delete the array, so when I'll delete the element, so what will be there? I think 1 will be here, 2 will be here, and 4 will be here. So now the updated indexing will be 0, 1, and 2. It will automatically get it updated, and the factorial value was 6. So here also now, here also I can say that I will have what, when I'm standing here as well in this permutation. So now in this case, you can see here I wanted 14th. So 14th is lying in between, right? I will have the 12th one, 13th one, 14th one, okay, 15, 16, 17. Okay, so from this will be this, so you can say, when I will do modulo with 6 now, so this will be what, when I'll do modulo with 6, you can understand why I'm doing modulo. So when I do modulo with 6, so this will be indexed as 0. When I'll do modulo with 6, this will be 1. When I'll do modulo with 6, it will be 2. When I'll do modulo with 6, it will be 3. When I do modulo with 6, it will be 4. When I do modulo with 6, it will be 5. So from 0 to 5, now I'm getting this thing, right? So that is why what I will do is, I'll update the k value. So the k value will be nothing but k modulus the factorial, right? So the k value will get updated to what? K value will get updated to 14 modulus 6. That is going to be nothing but 2. So it tells us that, okay, I want the third permutation here. In 3 also, I want this permutation, basically the third, actually I want the third one, right? So k will become 2. Is that clear, guys? Right. So since the k value becomes 2, then after the updated k value, I'll say that okay, since the k value is becoming 2, right? So just a second, since 3 is at this place and I have these many positions, right? So k value has become what? K value has become 2. Okay, so in that case, yeah, k value has become 2. So in that case, what I can say here is, like suppose 1 was here, then I had the option of 2 and 3, right? So with the help of 1, I can make 2 permutations, right? If I keep 1 at this place, if I keep 2 at this place, and 1 and 3 I have, so I can again make 2 more permutations. If I have 4 here, then sorry, very sorry, guys. So if I have 1 here now, then with the help of with the help of 2 and 4 I can make two permutations. Then with the help of, if I have 2 here, then with the help of 1 and 4 I can make two permutations. If I have 4 here, then with the help of 1 and 2 I can make two permutations. So if the k value is 2, so which permutation do you want, guys? Right, if you will number these permutations again, so this will be from 0 to 0 and 1th permutation, right? This will be what, 2 2 3, and this will be 4 and 5, right? So which one do you want? If k value is 2, so you want from this club, right? You want from this club, right? So which one you want? You want 2 at the starting. Please write 2 in the chat, guys. Everyone please write 2 in the chat. Okay, so you want 2 at this particular place, right? Is that clear? Are you getting? Because you want k is equal to 2, so the k is equal to 2 is present when the 2 is here, right? When the 2 is at this position. Please write yes in the chat, guys. When the 2 is at this particular position, that is when you want it. Are you getting my point? So when the k value is here, so your factorial will also decrease. So factorial will get divided by what? If the factorial was 6, it will get divided by the size of the array, that is nothing but 3. So now the factorial will become what? 6 by 3, that is going to be nothing but 2, because you can see now the clubs are now the groups are of size 2. So the factorial will decrease by the size of the current array, so current num array. So now factorial value is 2. So when I will which element do I want to get? So when I'll do k by factorial now, so when I will do what? So basically this is the 0th club. Are you getting my point? This is the 0th club, right? This is the 1th club and this is the second club. So I want this particular club now. I want this particular club because I want k is equal to 2. So 2th second club is present here now in the zero base indexing. So that is why I want this particular club. So I want 2 as the starting guy. Okay, I want 2 as the starting guy. So when I will do k by factorial, so when I'll do 2 by 2, so what will I get here? I'll get nothing but 1 here, right? So when I get 1 here, so this means that I want to take this particular guy. Okay, please write this. So this tells me about the index basically, right? Index that I want to take from the array. So I want to take this index as well as I want to delete it. So I'll delete it also, and I can say that I will place it here. Is that clear to everyone, guys? Is this part clear, guys? Please tell me. Nikaj, your code is a bit wrong. Okay, is this part clear? Please write +1 and hit the like button as well, guys, if you are clear with this part. Are you all getting this? Please tell me. Right, so I'll get 2 here. Is that clear that I'm placing 2 here? If that much part is fine, then only I can proceed further. Okay, so yeah, when I will take 2 as well, then I will have the elements left as 1 and 4, and let me do their indexing as well. Okay, so when I will delete again, so I will have the elements 1 and I'll have the element 4, and let me do the indexing. So this will be 0 and this will be 1 based index. So I can say that I have 3 and I have 2 here, and 2 more positions are remaining here. Okay, when 2 more positions are remaining, so what is the updated value of k that I need to see? So k value will be nothing but 2 modulo 2. Okay, because you can see k value will be what, when I will do update the k value, so it will be now k modulo factorial, right? Because 2 modulo 2 when I'll do, so I will get k value as 0. Okay, guys, cannot to stand what code limit is only. Okay, fine. Is this much part clear to you, all of you guys, or not? Right, so then I get the value as 0. So when I get the k value as 0 now, after updating, because I'm always going to take the modulus now for the next one, because if you initially see here, I had like if I had k is equal to 15, so first of all I did a minus minus, so I got 14 here. So this means I wanted the 14th one. Then after because of the 14th one, I was able to analyze that 3 will be here. Then I needed to take the modulus with 6, because now like after that, when I'll take the modulus with 6 now, then it became 2. Then the k value became 2, right? So in this I want the second one. Are you getting this point, guys? Every time I need to keep on taking the modulo. Anand is saying yes. What about other people? Rohi and Rishit and I think Naikaj is there. A lot of other people who are there. Anand is there. So guys, are you able to understand this fact or not? Please tell me. Like, what will be the leftover permutation now when you have placed a particular guy? See, when you have k is equal to 14 now, so when you do 14 by 6, then you are able to understand that you want the second, when you do 14 by 2, then you get 14 by 6, then you get the value as 2. So this means that you want the second index guy, that is nothing but 3 here. So you are able to fix 3. Then how will you get the rest of the things? So for the rest of the part, how will you get it? So you will have to take the modulus. So in the rest of the part, for 3 you want the second permutation. That is what it tells. So when you do 14 modulus 6, so you get 2. So this means after that you want the second permutation in this, and you keep on deep diving, you keep on subtracting it. Is that clear? So then you will have 0. So this means that you want to take like when you will do 0, and now the factorial value will decrease. So it will decrease by it will get divided by 2, so it will become 1. Since now the factorial value is 1 now, so you will do 0 by 1. So in that case you want this index. So you'll say that okay, I will place 1 here, Okay, and after that what you will do is, so you will delete this guy, and when you delete this guy, so 4 is only left and it is placed at the index 0. Then again if you will do again if you will update the k value, so you get 0 here. Now when you get k is equal to 0 at this place, then after that you do 0 modulo 1, so you get again 0. So now again after that factorial, when you divide it by size of the array, so factorial will still be 1. And again if you do 0 by 1, so you'll get 0 again, so you need to place this guy, so then you will place 4. So that is how we are getting the order 3214. Okay, I can cross verify it for you as well. If we have the k value suppose as 15 given. Okay, so just a second, if I have 15 given here now, so I'll just verify it for you. The answer should be 3, then 2, and then 1, and then 4. 3214. Let's check. So you can see here 3214 is the answer. Is this idea clear to everyone? Please give me a +1 and hit the like button if you are able to understand it, guys. Like leftover part will be what for the next permutation? It will be the k modulo this thing now. K modulo the factorial thing. Are you able to understand it, guys? Everyone, please tell me. Please write +1 and hit the like button as well, guys. I think you are not telling us. Is it understandable for everyone? See, initially the factorial value I started with n minus 1 factorial. That is why, because if the n value was 4, so I have to start with n minus 1 factorial. And if the k value is 15, so since I am taking 0 base index, so that is why I need to divide it by 1 also, right? That is what I am doing here. So you can see if the k value is 14, so it will lie in this group. So basically, how will I know that I have to place 3? So if I place it in an array and I do 14 divided by 6, right? So then I will get what? 2, index 2. So index 2 will tell me that I need the third guy. Like I need the guy 3. So that is what I can retrieve from the array. And once I've retrieved it, so after that, for the remaining number of positions, which permutation do I want? So in the remaining position, which permutation I want, I will get it by taking the modulus. So that is why I can say that k value will become 14 modulo 6, that will be 2. So in the remaining part, I want the second permutation. So as I said, if I keep 1 here, then I will get 0 and 1th permutation. And since the k value is 2, so you can say that I want the third permutation actually, so that I will get here. So again, if you see the updated array, so this is the updated array, and when you do 2 by 2, because the factorial will get updated divided by the size of the array. So now the factorial, because now factorial is 2, because only two groups are there now. So when you will divide it by 2 again, so it will become 1. So you need to take this guy index 1, that is the guy 2, so you'll place 2 here. That is what we are doing. Ujjwal is saying yes, Rishit is saying yes. What about Arohi and Naikaj and everybody else? Are you getting this point, guys? I hope that it is very much comfortable to all of us how we are getting to here now. Because if you see, the k value remaining was 2, so this means for the rest of the part I want the second permutation. So in that case, I need to say that if I place 1 at the first position, then I'll get 2 permutations. If I place 2, then I'll get 2 positions. If I place 4, so I'll get 2 positions. So I can say that k is equal to 2 is going to lie in the second group, right, when the 2 is at the top. So if I'll do 2 by 2, that is because the now groups are 2, so factorial will get updated by this divided by the size of the array. So size of the array is 3, so 6 by 3 will be nothing but 2. So I can see that the groups are of now 2 2. So that is how the factorial is going to reflect this thing. And again, if I do 2 by 2, so I am going to get the index as what? I'm going to get the index as nothing but 1. So this means I need to take this guy 2 and place it here. Okay, and for the remaining part I'll get that. Okay, this is clear. Very good, guys. So can we start writing the code if everyone is clear till now? That is how I've explained it. So what I will do is now I will have a string, let's say answer. Initially I'll mark it as null, and after having this answer, what I will do here is after having this answer, I can say that I will decrease the k value also, let's say. And initially what I can say is that I will take a vector also. So I'll declare a list in which I'll be storing the numbers. So I'll name it as num. Okay, just give me a second. Yeah, I'll declare a num array. And what I will do is I need to place all the elements. So I'll say that int I starts from 1. Okay, I is less than n, I plus plus. So first of all, I'll place the n minus 1 elements, because I need to take the factorial as n minus 1 now. If the n value was 4 now, so what was my factorial initially? My factorial will be 6, because I'm dividing in the groups of 6 first of all now. Right? Do you remember this part, guys? If the n value was 4, so initially the division was in the groups of 6. So that this means nothing but 3 factorial. So that is why I'm first of all going to take n factorial as well. So what I will do is factorial is asterisk is equal to I. So I'll first of all calculate n factorial here, and at the same time, first n minus 1 numbers I'm going to add in my answer. So I'll say that num dot push back this thing. I. So I'm going to push these numbers inside the answer as well, and only the number n is left. So after coming out of this array, I will push that number also. Is this much part clear to everyone? What I will say is push back n also. Is this part clear? And I have decreased the k value because I want the 0 based. Factorial is just nums minus 1. Yeah. So that is why I'm running I till less than n. So I'm calculating n factorial and placing all the numbers from 1 till n minus 1. I'm pushing all the numbers from 1 till n minus 1 inside this array. Okay. And then after that, I'm pushing the nth number here. Last number. Okay. Is this part clear, guys? Till now? Please tell me. Does it make some sense for everyone? Okay, then I will say that till when are you going to iterate? While the like till when are you going to iterate? So initially you will say that we don't know till where we are going to iterate. So we can mark it as an infinite loop. And then what I will say is that which index guy do I want? So I can say that let's say int index, which index of the array do I want? So I can say that I want k divided by the factorial. Okay, that is what I want. That is the index that I want. So I will say that answer plus is equal to I will do 2 underscore string and I will take the num index guy. Okay, so I'll take that guy from the string since we are sorry, since we are having an integer array, no? So I will take this particular guy and then I will convert it into string. Is that clear? Guys, please tell me, is this part clear how I am doing this? So first of all, you get the index. So index will be nothing but k divided by the factorial. So then the guy that you want is num in the num array you want this particular indexed guy, right? So you get it. Once you get this guy, so since it is in number, so you want to have it in string, so you will convert it into string. Now if you are having 4, so you actually want string like 4, no? Right? So that is why we want all the numbers in the string format. So that is why I'll convert into string so that I can add it easily. Is this part clear to all of you guys? Please tell me. Is that understandable? Right. Then what we'll do is we'll do k is equal to k modulo fact. So then for the next part, na, I have to get the reduced value of k. Right. As I said, if the k value was 14, then if the k value was 14, then I will do 14 modulo 6 initially because I need the second group now. Right. I need the second permutation now for the remaining part. Okay. So that is what is indicated here. Then what I will do is I'll say that okay, after doing this particular thing, what we can say is we will also do one more thing, that is num dot erase. We'll use a erase function. Okay, so num dot erase I will do, and here what I'm going to do is num dot begin. Okay, from the starting of the array I will plus index. So the index that I have taken, no, that particular guy I am going to remove from the array as well. And so I will just remove it after taking it. That will look better. Okay, I'll remove it and then I'll have the updated k value, and the factorial value will also be updated. So factorial is equal to factorial divided by the num dot size. Okay, so whatever is the updated size of the array, this array will be updated to 3. So 6 by 3 will become what? 2. So that is how the factorial is going to get updated. And one more thing that I need to check is, if suppose that after deleting, if the size of the array becomes 0, then I cannot take anything. So that will be my breaking point. Is this part clear, guys, or not? Please tell me. Are you able to understand this, everyone? Just give me a second. Yeah, so basically I'm first of all getting the index will be nothing but the k divided by the factorial, and whatever that guy I am getting from the array, since it is an integer, so I'll convert it into string by using the toString function, and I'll add it into my string answer, and then I will erase it from the array. Once I've erased it, so I'll check that since I keep on erasing, so whenever the size of the array becomes 0, then I will say that I should stop because I have placed I have got my permutation. Otherwise what I will do is I'll update the value of k, so k will be equal to k modulo factorial initially, and then I'll update the factorial value as factorial is equal to factorial divided by num dot size. That is since initially the factorial was 6 and I'm going to divide it by 3, so it will become 2 in the next iteration, right? That factorial is going to indicate the number of groups actually. Okay, then after that, in the end, we can simply return the answer. So is this part clear to everyone, guys? Please tell me. Are you able to understand the approach much more clearly now or not, since we have done a lot of dry run here for this problem? So is it clear or not? Okay, it says that factorial was not declared. So yeah, what I will do is I will declare the int factorial initially as 1. I think this is going to work. Let's try and compile it now. Could you please explain how we are updating factorial? So yeah, how we are updating factorial, na Naikaj. So what we are doing is, see, initially the factorial is like factorial is kind of indicating the group, right? Factorial is initially 6, right? Because I'm taking n factorial. Then after that, see, factorial is indicating the number of the group size that we are having. So initially we are having 6, right? 6 here. Then after that, you will have what? After that, you will have 2 groups. So then you need to do what? 6 by 3. So actually that will become 2. So then after taking one element of the array, the size of the array becomes 3. Okay, so you divide 6 by the size of the array. So you divide factorial by the size of the updated array after deleting the element. So that is why we are doing this thing. Are you getting? And k is the updated factorial. Now, if you will see, k value was 14. So 14, when I'll do 14 modulo 6 now, so I will get the 2 value. So this will tell me that okay, after placing that guy, I want for the rest of the part I want the second permutation. Okay, is that clear to everyone, guys? Please tell me. Is this part clear or not, guys? Okay, so you can see here it is just running order of n times, right? But I am using the delete operation also, na, erase operation. So erase operation for one time it takes order of n. So if I'm running the loop n times here, so in because I'm keeping n elements at each position, so for one element erase it takes order of n times. So for if there are n operations, so order of n square time overall will be the time complexity, and the space complexity is order of n because I'm placing all the n elements in the starting. And now I will try to submit it. I think this code should get accepted as well without any errors. Let's see. Yeah, it gets accepted. So is this problem clear to everyone? Please give me a +1 in the chat, guys, if you are clear with this problem. Whenever the elements get exhausted, whenever you have placed all the elements, that is when you will break. And after after using the index, right, you will add that element in the final string, and you will erase it from the array. If the array size becomes 0, then you will break. Otherwise, what you will do is you will get the remaining part. What is the remaining? How will you solve the remaining part? So for that, you need to use k is equal to k modulo factorial. Now that is how you are going to get what is the permutation that you require for the rest of the elements, right? So you want the second permutation or what permutation that you will get by doing the factorial modulo, na? And similarly you need to update the factorial, because if initially you are having 6 groups, then you will have 2 groups, right? So two groups each, you can see here, if one is here then two 4, so 2 groups each. So that will be nothing but 6 divided by the size of the updated array, so 6 divided by 3. Okay, is that clear, guys? Make sense or not? And initially I've done k minus minus as well. So what I will do is I'll just open the GFG ID. Is it clear to everyone, guys, or not today? This session was quite long, but I hope that you have understood everything in this session, right? And it is a very good problem. It has been previously asked in Amazon, Microsoft, Adobe, Google, and Microsoft as well. So it has been asked in a lot of companies. Did you enjoy this problem, guys? Like Arohi is there, Anand is there with us, Ujwal is there, and Rishit is there with us, Naikaj is there, guys. Did you enjoy it? Okay, let me paste this here. Right, so I have pasted the code in the chat, and this problem has been asked in a lot of companies. I would rate it as a harder problem, not a basic medium problem, but it is a harder level problem. So guys, you can hit the like button if you have understood till now. In the solution we use for fact variable, how we confirm that int won't overflow. How we confirm that int would not overflow, because in this case now you can see here that the n value is less than equal to 9 now. So you are only calculating till 9 factorial maximum. Like, see, you will calculate in n minus 1 factorial maximum now. So it is not going 8 factorial is not going to overflow because the n value is very low. So that is why it is not going to overflow. Okay, Naikaj, sorry, Rishit. Right, so since the n value is very small, so it is not going to overflow. That is why. Okay, you can see here now it is mentioned that n is between this value and this value, so that is why it will not overflow. If it is clear to all of you guys, please hit the like button and give me a +1, and then I will proceed. All right, so I think that you have understood this problem. Okay, if you want to understand it again, right, so you can watch the recording at 2x, and you will understand it once again much better. This is a very good problem, and it is frequently asked in companies like Adobe, Amazon, right? So again, I'm telling you the name of the companies. So although GFG has not mentioned the company tags, but still this problem has been asked in Adobe. Okay, it has also been asked in Amazon, right? It has also been asked in Microsoft, it has also been asked in Google, and a lot of other companies also that even I'm not able to mention. So yes, it has been asked in a lot of companies. Please make sure to try it out on your own as well. So did you enjoy today's session, guys? I hope that you did, right? So really great. Thanks a lot, guys, for joining for this particular session. I hope that you enjoyed today's session and you learned something new. Thanks a lot, Shanti Singh, as well. Thank you, everyone. Thank you, Arohi. Thank you, Ujwal. Thank you, Rishit. Thank you, Naikaj. And thank you, Anand, as well. Thanks a lot, guys. And I'll see you with another problem of the day in the next week. Okay. Make sure to solve today's problem of the day. And Abhinav will be discussing it tomorrow. Okay, and if you have any doubts, please make sure to write them in the comments, and if you understood, so after this video is over, make sure to comment understood as well. With that being said, thank you everyone, and I'll see you in the next live session next week. Thank you guys, take care.